Okay, so this video we are going to discuss uh, paper 9709, paper 61, all right, which is a probability and statistics 2 for May June 2022. Okay, so let's start with the question number 1. All right, so for question number 1, they give us some information about the diameters in x milliliters of a random sample of 200 discs made by a certain machine. So these are the summarized data that we have. All right, we are having the n summation of x and also summation of x squared. And they want us to calculate a 95% confidence interval for the population mean diameter. So before we can get the 95% confidence interval, generally for this question, right, we are having all the values that is from sample, from a large sample. And before we can find the confidence interval, right, we actually need to have the population mean and also population variance. All right, so we need to have population mean and population variance, but now we are having the sample value only. Therefore, we have to get out the unbiased estimate for the mean and variance of population first. All right, so this is a sample. So we can use the sample value to calculate the confidence interval. So we need to get the unbiased estimates for mean and also the variance for population first. All right, so what's the correct formula, or what's the formula that we can apply for this? Okay, so generally this is what we have. You can get this formula from the formula booklet, MF19. Okay, so let me bring it up so that you can refer to it. So to get the unbiased estimates for the population mean and diameter, right? Generally this is a formula that we can apply. Okay, so to get the mean, you can see that to get the mean, it is actually summation x over n. Okay, so we are using x equals to summation x, which is 2520 divided by n. So our n here will be 200. All right, so very easily, I already get the unbiased estimates for the population mean, which is 12.6. And now I want to get the unbiased estimates for population variance. All right, so to get the unbiased for population variance, generally, you can apply either this formula or this one. So for me, I'm using this because I'm having all the information from this formula. So 1 over n minus 1, that means 1 over 199. And then summation x squared, you can get it from here straight away, 31852, minus the summation of x 2520, and you square it, divided by 200. Alright, so for this question, if you try to simplify everything, you have 100 over 199. Okay, so for me, I will just keep it in the fraction form because we are going to apply it later in our calculation of getting the confidence interval. So I'm not going to calculate out the decimal number first, okay? I will keep the answer in fraction form. Okay, so to get a 95% confidence interval for the population mean, generally, you just need to apply formula. Okay, so for a 95% confidence interval, the formula that we are having generally will look something like this, where we are using the sample mean. Okay, so minus the z, standard deviation of the population, divided by square root n. So the upper limit will be sample mean plus z, standard deviation over square root n. Oh, okay, sorry. So just now I mentioned it wrongly. To get the interval, right, generally we need the sample mean only. Okay, we are using all these sample mean and also the population variance to get the limit where the population mean lies. All right, so we are referring this mean as a sample mean in this case, right, in the 95% confidence interval. Okay, then now I will just need to substitute all the value from here. Okay, so I already calculate sample mean just now, right, which is 12.6. And then definitely I need to find the value for z first before I can continue for the calculation part here. Okay, so how can I get the value for z? Okay, so to get the value for z, generally you can imagine that we are having a normal graph. Okay, so 95% means you are having 95% in the center. Okay, so we are having both sides here. Okay, so for each side here, generally it will be 0.025 and also 0.025, the area. So that when you total up all the area here, it will be equals to 1. And this is the value of Z actually. Okay, so to get the value of Z, generally what you need to do is that you have to referring, okay, to the value of Z that has, okay, the probability of 0.975. So you can see that this whole area, the purple color one, is 0.975. Okay, so by referring to the probability 0.975, we can get the value of Z. So how can we get the value of Z? Okay, so looking for 0.975, generally you can scroll down to the critical value for the normal distribution here, and you can see that for the probability of 0.975, our Z value is actually equals to 1.96. Okay, so you can substitute the Z value as 1.96 in this case. Okay, so from here I know that this is actually 1.96, so I just substitute the value in. So I'm having negative 1.96. Standard deviation means the unbiased estimates standard deviation, and that we calculate just now, where it should be 100 over 199 divided by n, so divided by 200. Okay, so the same thing happened for the upper limit, just that we change the sign become plus. Okay, so by trying to press the calculator right and simplify the answer to 3 significant figure, we should get 12.5 and also 12.7. Okay, so this is how we actually get the 95% confidence interval. Okay, all right, so this is part 1. And now we proceed to the next part, which is part number B. Okay, so for part number B, they are saying that John chose 40 random sample, okay, and use each sample to calculate a 95% confidence interval for the population mean diameter. So they're asking how many of this confidence interval would be expected to include the true mean of the population diameter. So when we are talking about the confidence interval that includes the true mean in the confidence interval, right? That includes a true mean. Generally, it is referring to the percentage here. So when you're having 95%, it means that we have 95% confirmed that the true mean lies in the confidence interval. So they are saying that for 40 random sample, right? So how many of them contain or include the true mean in the confidence interval? It will be 40 multiplied with 0.95. So 95% of the 40 random variable will include the true mean, where the value that you get should be equals to 38. Okay, so this is how we answer the question number 1. Okay, so question number 2. Arvin used an ordinary fair 6-sided die to play a game, and then he believes that he has a system to predict the score when the die is thrown. So before each throw of the die, he wrote down what he thinks the score will be. So he claims that he can write correct score more often than he would if he's just guessing. Alright, so I think there's one important keyword here. This is the keyword more often to help us set up the alternative hypothesis. Okay. All right, then his friend lets me test his claim by asking him to write down the score before each of the 15 throws. So this one will be our total number of trial, okay, of the die. So Arvin writes the correct score exactly 5 out of 15 throws. So from the 15 throws, right, he writes the answer correctly for 5 times. So the 5 here, to me, it will be the observed value that we are going to use it to calculate the p-value later. So observed value. Right? Okay, so these are some information that we have, and after that, they want us to test Arvin's claim at the 10% significance level. All right, so to carry out this test, generally we are having the number of trial here, and after that, they are talking about the fair 6-sided die, right? And to predict the correct score, okay, if we are just guessing, when we want to We are just guessing, trying to guess the probability of us, the probability of getting a certain number right from the die. Generally, when you are guessing, the probability will be either smaller or equals to 1 over 6 only, because you're having a six-sided dice, right? Okay, if you are purely guessing, the probability that you get the answer correct, it will be definitely smaller or equals to 1 over 6, because you are just guessing. And then the keyword more often here generally telling us that they are having a higher chance, okay, to get the answer correct, where the probability will be more than 1 over 6. So when you're having this sign greater than without the equal sign, so it belongs to the alternative hypothesis, and this one we will have it as a null hypothesis. And because of we are having the equal sign here, right? So in our syllabus, we are only considering or putting it as p equals to 1 over 6. Right, so this is how we set up the question. Okay, so let's start. So we are having the null hypothesis where the probability is equals to 1 over 6. And after that, for the alternative hypothesis, I'm having the probability of p greater than 1 over 6. Okay, so p greater than 1 over 6, what is the meaning of this alternative hypothesis? It means that Arvin, okay, can write the correct score more often than just guessing. More often than just guessing. Okay, so that's the meaning for the alternative hypothesis. All right, so since we know that we are going to test the proportion, right, the probability for some certain event, okay, generally this is a binomial distribution with the n. So the total number of trial is 15 just now, and also the probability will be 1 over 6. Okay, so we should know that this is actually a binomial distribution. And to carry out the test, now I need to calculate the p-value. All right, so to get the p-value, I need observed value. So the 5 just now is the observed value from our experiment. Okay, and then to calculate the probability, generally we are going to calculate the area or the p-value, area or p-value of the side, okay, of uh, each side. All right, so for this one, we are having greater than 1 over 6. So greater means that we are having one tail test, and then we are interested at the area on the right hand side. So right hand side means that you should calculate the probability for x greater equals to 5. Okay, right? Yeah, then now we are going to start with the calculation. For x greater equals to 5, by using the binomial distribution, you can take 1 minus. So I'm having 1 minus the probability of x smaller than 5. Okay, so to calculate this p-value, I have to apply the binomial distribution where it will be starting from x equals to 0. So x equals to 0 means that I'm having 15c0, 1 over 6 power 0, and then 5 over 6 power 15. Okay, and after that, I'm having x equals to 1. So 15c1, 1 over 6 power 1, and also 5 over 6 power 14. All right, so you can see that we're using binomial formula to calculate the probability. So you should continue all the terms here, right, until 15c4. 5 is not included, therefore you have to include until 15c4. So I'm having 1 over 6 power 4, and then 5 over 6 power 11. Okay, so if we didn't do any careless mistake by pressing calculator, by right, this answer should be 0.0898. Okay, so for your information, this is actually the p-value that we have for this test. Okay, so when we want to make a conclusion, we have to compare the p-value with the significance level. Okay, so just a very simple diagram to help us and visualize our result, right? Okay, so let's say we are having a binomial distribution. I assume that this is the probability bar, all right? Okay, so for this case, we are having one tail test on the right. Therefore, we should expect that our rejection region is actually on the right hand side. And this area is our significance level, which is 0.1. Okay, so we are referring to the area when we are having all these p-value and also the probability here. Okay, so the significance level is 0.1, which is this area I assume. So this area will be my rejection region. The non-shaded area will be the acceptance region. Now I want to compare my p-value with the significance level. So you can see that the p-value, okay, is 0.898, where this area should be something smaller than the 0.1. So that means the area that I get might be this one. Okay, the black color one. So this black color one will be 0.0898, where it is the area smaller than 0.1. So if I want to sketch it or visualize it, right, it should be under this part. And you can see that for this particular value here is actually a 5, x equals to 5. Okay, so for this x equals to 5, this particular value of 5, you know that it is falls under the rejection region. Because that's why I told you, right, for this green color, the whole area is the rejection region. And for the area that I calculate, it is smaller than the rejection region. And you can see that the whole area lies under the rejection region. Okay, therefore, as a conclusion, we actually have to reject the null hypothesis. Okay, so before you write out the conclusion, you should try to write a reasoning statement. So the reasoning statement is because of the p-value, okay, so which is equals to 0.0898 is smaller than the significance level, which is 0.1. Okay, so because of this reason, we are going to reject the null hypothesis. Okay, if we reject the null hypothesis, it means what? It means that this statement is actually correct, right? Okay, so you can write out a conclusion here. There's enough evidence to show that Arvin can write the correct score okay, the correct score more often, okay, so more often than just guessing, something like this. Okay, so generally this is how we carry out the test. All right, then this diagram is actually to help you visualize it only. If you can't really remember the result or the reasoning statement, so you can use the diagram to help you and visualize it. But of course, in your solution, you still need to write out the reasoning statement. Okay, all right, so this is how we solve question number 2. Okay, question number 3, we are having the length in centimeter for two types of insect, and then they are modeled by random variable x and also y. So both x and y, you can see that they are normally distributed. Okay, so they want us to find the probability that, okay, so if you want to translate the sentence into symbol, right? Generally, it should be find out the probability. So this is P. A randomly chosen type A. A randomly chosen type A means that there are one insect from type A or type A, which is the X. Okay, greater than. So greater than means greater than the sum. So sum means total of the length of 3 randomly chosen bee. So you're having 3 types of bee insects. Oh, sorry, three. You're having 3 type B insects. All right. So when you want to write the symbol, it should be x greater than 3y. That means this one actually is y plus y plus y. So you can simplify, become 3y. So to calculate this probability, we cannot proceed unless we move all the variable to one side. So if I move variable to one side, I'm having x minus 3y greater than 0. Okay, so before I calculate the probability, I need to find out the mean and variance for x minus 3y first. Okay, all right, so how to get the value for expected value x minus 3y? This is the mean. All right, so this is the mean for x minus 3y. So to calculate the mean for x minus 3y, you take the mean for the x, which is 6.2, minus, you just copy the minus, 3, you just copy the 3 times of the mean of y. So the mean of y is 2.4. Okay, so if you try to get the answer for this part, the mean should be equal to -1. And after that, we need to get the variance. All right, so to get the variance, it will be a little bit special. Okay, so for variance, right, we are taking the variance of x. So for the range of x, it is 0.36. Okay, then for variance, right, there's no negative, okay, in our calculation here. So it should be always a positive. Okay, and then we are having 3y. Okay, so for the 3y here, please have a look for the original question. They are telling us about the sum. So when they are telling us about the sum, right, that means it is the total. So when you get the variance, right, it should be also a total. So the 3, no need to square. Okay, no need to square because it is the sum. It is not the multiple or the times. All right, it is a sum or total. Generally, when you want to get the variance, you no need to square the constant number. Okay, so you're having 3 times of the variance of y, which is 0.25. So from here, if you try to simplify the value, you will get 1.11. Okay, so since the x is normally distributed, y is also normally distributed. Therefore, x minus 3y, the linear combination of x and y, also normally distributed. So you can write a symbol like this, where x minus 3y, we know that they are normally distributed with the mean -1 and also the variance 1.11. Okay, so now we come back to the question. So they want us to calculate the probability for x greater than 3y, where it should be x minus 3y greater than 0. Okay, so since we know that x minus 3y is normally distributed, therefore we can change it become z before we calculate the probability. So we take the value minus the mean divided by standard deviation. So our standard deviation will be square root 1.11. Okay, so from here, we can get the value for z, which is greater than 0.949. Okay, so z greater than 0.949. Generally, I want to find out this area. This is the area that we want to find out, and this is z equals to 0.949. Okay, so from the normal distribution table, we will actually get the value that's smaller than the particular number. Therefore, to get the area, you have to take 1 minus then the value that we get from the normal table. All right, so normal table is 0.949. So let's have a look for 0.9 and 4. Generally, we are having this value 9, 4, and then 9 again. So for the 9 here, you actually have to add 23 at the last 2 digit of this value. So 8264 plus 23 at the last digit here, you should get the value, which is 8287. Okay, and then from here we can simplify the value, correct to 3 significant figure, where it should be 0.171. Okay, so this is how we actually solve the linear combination probability question. Okay, question number 4. We are having the independent variable x and y, where x is Poisson distributed and also y is binomial distributed. Okay, so they want us to find the mean and also the standard deviation of x minus 3y. Okay, so before we start to find out the mean and standard deviation for x minus 3y, maybe we can try to identify what are the mean and also the variance for both x and y. Okay, so x is Poisson distributed. Therefore, from here, we actually know that the mean for the x and also variance of the x are having the same value, where both of them are equals to 2, because x is from Poisson. So for Poisson, our mean and variance are the same. Okay, then when we are having the y is a binomial distributed. To get the mean for the y, generally we are using n times p. So n is the first value here, which is 20, and then the p is 1/4. So when you try to take n times p, I will get 5. So this is the mean of the y. And we also need to get the variance of y. Okay, so to get the variance for y, the formula will be npq, where n is 20, p is 1/4, and q is 3/4. So 20, 1/4, 3/4. Okay, so from here, right, we should actually try to get the value for the variance of y, which is 15 over 4. Yeah, then once we identify all the mean and variance for x and y, then we can start to answer the question. So they want us to calculate the mean or find the mean for x minus 3y. So to find the mean, which is expected value for x minus 3y, generally we are using the mean of the x or expected value for x, which is the 2, minus 3 times of the expected value of y. So expected value of y is 5. So it will be equals to 2 minus 3 times 5, which is negative 13. Right? And after that, they want us to get the standard deviation. So before the standard deviation, we need to calculate the variance first. So I'm going to find out the variance for x minus 3y, where it should be variant x. So the variant x is actually 2. For the negative sign here, in finding out the variance, right, it should be always positive. There's no negative, okay, in the linear combination of the variance, right? So it should be a positive. And then 3, when you want to take out the 3 from the variance, you need to square the constant. So you will have 3 square and multiply with the variance of y. So the variance of y is 15 over 4. Okay, so we can try to get the answer for this variance of x minus 3y. If you simplify, you have 143 divided by 4. And since they are asking for the standard deviation, so the standard deviation of x minus 3y, you have to take the square root of the variance. All right, so we're having 143 divided by 4. And by pressing calculator, we will get a exact value, which is 143 over 2. Or you can change it, become 3 significant figure, where it should be equals to 5.98. Right, so this is what we have for the first part of question number 4. All right, then now we proceed to the second part. Okay, so for the second part of question number 4, they're asking for y equals to 15x. Find out the probability y equals to 15x. Okay, so let's just recall again. Our x is Poisson distributed where the mean is a 2. And for the y, it's binomial distributed where our n is 20 and then we're having 1 over 4. All right, so we have to take note also for the value of x, right? We can take value of x which is equals to 0, x can be equals to 1, x can be equals to 2, can be equals to 3 until infinity. For the value of y can be equals to 0, it can be equals to 1, it can be equals to 2, and so on. And the largest value for y that we can consider is y equals to 20. All right, so for this question, they're asking for y equals to 15x. So under what value of x and y, I will get this relationship where y equals to 15x. Okay, so maybe you can start from x equals to 0. If x equals to 0, then what happened to the y? So the y equals to 15 times 0, which is equals to 0. Okay, because y equals to 15x, right? So y equals to 15 times 0, you will get a 0. Therefore, the first possible case is I can have x equals to 0 and also y equals to 0. Okay, so do we have any other case? How about if we consider when x equals to 1, what will happen to the y? So the y will become 15 times 1, where your y is equals to 15. Okay, so you can see that x equals to 1 is a valid value like in the x, and then y equals to 15, it is also valid, right? Because y can be any number between 0 until 20. Therefore, this second case also we will accept it where x equals to 1 and y equals to 15. Okay, so what is the next case? We will consider x equals to 2. When x equals to 2, if you try to substitute the value 2 into the equation, you have y equals to 30. But you can see that for y is binomial distributed, it is bounded by the value of n. So in this case, the maximum value for y can be only 20. But now if you substitute x into the equation, you are having y equals to 30, which means that this is not the correct answer. There's no such case where y equals to 30. So if you if you continue further, x equals to 3, you realize that the value for y getting bigger and bigger, bigger and bigger. Therefore, all these values we will just ignore. So for this question, right, there are only two possible cases where y can be equals to 15x. The first case is x equals to 0, y equals to 0. The second case is x equals to 1 and y equals to 5. So let's find out the probability here. Since these variables are independent to each other, so we can just calculate the probability separately. So as an example, when x equals to 0 in Poisson distribution, the formula that we have is e negative lambda power 0 divided by 0 factorial. Multiply with the probability of y equals to 0, where we are having 20 C0, 1 over 4 power 0, 3 over 4 power 20. How about the next one? So for the next one, I'm having x equals to 1. For Poisson, it will be e negative lambda power 1 divided by 1 factorial. And how about the y equals to 15? So when y equals to 15, it is binomial. Therefore, I'm having 20c15, 1 over 4 power 15, and then 3 over 4 power 5. Okay, so if you try to press the calculator and also get the answer, the final answer, it will be equals to 0.00430, correct to 3 significant figure. Right, so this is how we answer question number 4, part B. Okay, so we are now at question number 5. The car arrived at a fuel station at random and a constant average rate of 13.5 per hour. So to me, right, this keyword per hour actually is a time interval given, and it tells us that this question belongs to Poisson distribution. All right. Okay, so first they want us to find the probability that more than 4 cars arrive during a 20-minute period. So for 1 hour, we are having 60 minutes, right? And then now we are interested to find the probability for a 20-minute period. So before we calculate the probability, we need to find out what is the lambda, or what is the mean for a 20-minute period first. Okay, so 13.5 is for 60. Therefore, to get a 20-minute period for the lambda, right, you should take 13.5 divided by 3. Okay, so if you take 13.5 and divided by 3, you get 4.5. So your lambda for this case is 4.5. They are asking for the probability more than 4 cars arrive. So for more than 4 cars arrive, we should write out x greater than 4. For Poisson distribution, x greater than 4, that means you have to start from x equals to 5. So x equals to 5, x equals to 6, x equals to 7 until infinity, which is impossible for us to complete the calculation. So you have to take 1 minus the opposite sign for the 4. So I'm having 1 minus x smaller equals to 4. Okay, so apply the Poisson formula, e negative lambda. The first term, x equals to 0, is always a 1. The second term, it is always the lambda. Then the third term is this is x equals to 0, x equals to 1, x equals to 2. So for x equals to 2, you're having 4.5 squared divided by 2 factorial. When x equals to 3, it will be 4.5 power 3 divided by 3 factorial. All right, and also, sorry, I made a careless mistake here. It should be a 4. Okay, so we should stop at x equals to 4. So when x equals to 4, I am having 4.5 power 4 divided by 4 factorial. All right, so we apply the Poisson formula and press calculator and simplify our answer for this case. The final answer that we get should be 0.468, correct to 3 significant figure. Okay, so this is what we have for part A. Now let's proceed to part number B. Okay, so for part number B, they tell us a very obvious keyword, use an approximating distribution. So that means you might need to change Poisson, become some other thing else. All right, so to find the probability that the number of the car that arriving during a 12-hour period is between this number. Okay, so again, our original mean is about 1 hour per hour is 13.5, right? So now I'm having 12-hour period. That means I am lambda. If I want to get the lambda, it should be 13.5 multiplied with 12 because 13.5 is for 1 hour per hour. So now I'm having 12-hour period. Therefore, you should take 13.5 multiplied with 12. The answer that you get for this lambda will be 162. Since the lambda already more than 15, therefore you can change the x become normal distribution. Okay, so for normal distribution, we need to input the mean and also the variance. Mean and variance for the Poisson distribution both are the same, where I should write 162 here for the mean and also 162 for the variance. All right, then now they want us to calculate the probability that they arrive on between 150 and 160 inclusive. So inclusive means should have the equal sign. So when I write the correct symbol, it should be something like this. It is between 150 to 160, right? Inclusive means that you need to put the equal sign for the value here, for the symbol here, right? Okay, so now we are changing from Poisson to normal distribution. Poisson is discrete and the normal is continuous. Therefore, we should apply continuity correction before we calculate the probability. So the first step here, I will want to apply the continuity correction. Okay, so 150, you should put it as 149.5. And then 160, you should put it as 160.5. Okay, so this step is standardization, is the continuity correction. And then after that, to find the probability, you should try to standardize the value. So to standardize the value, you take 149.5 minus the mean. So this is the mean divided by standard deviation. Okay, so after you standardize it, it will become Z. So the same thing happen for the upper value here, 160.5 minus the mean divided by standard deviation. All right, so from here, I'm having negative 0.982 and negative 0.118. Okay, so there are many ways for us now to find out the area for this part. Generally, for me, I'm using Z smaller than the area at the back, smaller than negative 0.118 minus Z smaller than the negative 0.982. Okay, then now we need to try to find the probability for all these. So first, we are looking at this one. So Z smaller than negative 0.118, it is equals to 1 minus Z smaller than positive 0.118. So I'm looking for the probability of 0.118, 0.11, which is this one, 5438, and then plus 8. That means you have to plus 32. So when you try to plus 32, right, you should get 5470. 5438 plus 32, you should get 5470. So we go back to our solution here. Okay, so for this part, generally we are having 1 minus 0.5470. Okay, so maybe I put a sign here. So this one belongs to this whole thing. All right, then minus, I just copy the minus. Now I'm looking for the area Z smaller than negative 0.982. So the steps are generally the same, right? So you're having 1 minus, okay, looking for 0.982. 0.9. So 0.9 is this one. 8 is this. 8365. 2. 2 is a 5. So 8365 plus 5. So when you take 8365 plus 5, you have 8370. So again, if I want to continue the calculation for this part, I'm having 1 minus 0.8370. So try to simplify the answer, you'll get a very nice value where it is equals to 0.29. Okay, so this part basically is for this whole thing. Okay, so let's proceed to part C. Okay, so for part C, beside independently of cars, right, the trucks arrive at the fuel station at random and the constant average rate of 3.6 for 15-minute period. So the truck one is 3.6 for 15-minute period. They want us to find the probability that the total number, okay, so the total number of cars and also the truck arriving at the station during a 10-minute period is more than 3 and less than 7. Okay, so now we are interested to find the probability for total, okay, in 10-minute period. Okay, so first of all, we need to figure out what is the total lambda for this 10-minute period. Okay, all right, so generally what should we do here is, okay, we are having the x, right? Just now you know that x. Okay, so maybe I write it like this. For the x, the lambda is equals to 13.5 for 1 hour. Okay, and now I want to find out the mean for 10 minutes. So the mean for 10 minutes will be 13.5 divided by 6. Okay, so 13.5 divided by 6, you will get a nice value where it is equals to 2.25. And this is actually for 10 minutes. The same thing applies for the truck. So the truck, maybe I label it as a Y. Okay, so for Y, right, I know that 3.6 is for 15 minutes. So now I'm interested at 10 minutes, for 10 minutes. So for 10 minutes, right, you should take 3.6 divided by 15 times 10. Okay, so use some small calculation on ratio. So you take 3.6 multiplied with 10 divided by 15. Okay, so we get a nice value also, which is equals to 2.4. So maybe I write like this. It is equals to 2.4, which is for 10-minute period. Oh, sorry, 10-minute period, correct. Then now, when you want to calculate the total number of cars and truck, right? So the total you can write out as T lah. So what is the mean for T? So the mean for T, generally you are adding the X with the Y together, where you are having 2.25 plus 2.4, and it is equals to 4.65. So this is actually your new lambda, all right? So you can write out again. T is Poisson distributed with the lambda 4.65. Okay, then now they want us to calculate the probability where the truck arrive, right? The car and the truck arrive more than 3 but less than 7. Okay, so they want us to calculate the probability for more than 3. T is more than 3, doesn't include the 3. And then less than 7. So less than 7 means smaller than 7. Okay, so since the T is Poisson distributed, therefore all the value for T should be in whole number. So greater than 3, what are the possible values that is greater than 3? So we are having T equals to 4, T equals to 5, and also T equals to 6. So you should include these 3 for the calculation for probability part. Okay, so again, I apply the Poisson formula, E negative lambda. So the lambda now is 4.65. Okay, so when when T equals to 4, right? So you should have 4.65 power 4 divided by 4 factorial. When T equals to 5, then you have 4.65 power 5 divided by 5 factorial, and also 4.65 power 6 divided by 6 factorial. Okay, so simplify this answer by using calculator, you should get 0.494. Okay, so this is how we solve question number 5. All right, so question number 6. we have a random variable x with the probability density function f, and then the graph of fx is a straight line segment parallel to the x-axis from x equals to 0 until x equals to a, where a is a positive constant, and state in terms of a the median of x. All right, so if let's say we try to imagine, right, how is the graph look like? So generally for this PDF, it is generally a horizontal line, which is parallel with the x-axis, and it is from 0 until a. Okay, and then this is my function fx, and this is definitely the x. Okay, right. So when we are having this kind of graph, right, generally it is a symmetric graph. Where it is a rectangle, you can see that it is a rectangle and it is symmetric. Okay, so when you are having the graph on which is a symmetry for PDF, generally the median will be actually in the center. So it will be in the center, okay, of the whole graph. All right, so where's the median here? So since you are having from 0 until a, therefore the median should be a over 2, which is in the center. Okay, so we can just list out the value where the median is equals to a over 2. Okay, so this is how we get a median by using some very basic idea. Okay, then now we proceed further. They are asking for the probability that x is greater equals to 3 over 4a. Right, so basically, again, I want to show it by using the diagram again. Okay, so first of all, I actually need to know what is this value. Okay, and we know that the whole area under the graph, or the whole area for the rectangle, should be equals to 1 when we are having a continuous random variable. Right, so if let's say we are having the area, it is equals to 1. So to get the area, we are having the base. The base is actually the a, and the height is actually the y, right? So you can put in y, a multiplied with the y, it is equals to 1, and therefore your y is equals to 1 over a. So this particular value is actually 1 over a. All right, then now they're asking for the area, the probability that x is greater than 3 over 4a. So to get the 3 over 4a, it might be somewhere here. This is 3 over 4, and this is a. So to calculate the probability for x greater than 3 over 4a, we are interested to find out this particular area, purple color. Okay, so by common sense, if you want to get the value for x greater than 3 over 4a, I want to find out the area for this purple color. So again, the base for this rectangle is actually a minus 3 over 4a, and then the height for this rectangle is actually 1 over a. So if I try to simplify, I'm having 1 over 4a multiplied with 1 over a. So you can simplify off the a here, and eventually the area that you get is 1 over 4. So this is the area, which is also the probability for x greater than 3 over 4a. All right, and now we will proceed further. Okay, so for part C, so we are still having part C here. All right, so for part C, we want to find out we want to show that the variance is equals to half 1 over 12a squared. All right, so first of all, if you refer back to the diagram here, generally it is a symmetric graph, right? So for symmetric graph, again, besides the median is in the center, the mean is also at the center. All right, so this is actually the median, which is also the mean, which is a over 2. All right, so I can write out the expected value for the x is equals to a over 2. And to get the variance, I need to find out the ex squared first. Okay, so to find the ex squared, basically you need to take the integration. For our equation here, I should have integrate from 0 until a, and then multiply in x squared into the function. And if I go through the integration, I will get the expected value for x squared. But now I need to know what is the function fx. Again, if you refer back to this diagram again, since the y is equals to 1 over a, right? And it is a horizontal line, therefore the equation is equals to y equals to 1 over a. Or you can rewrite it become fx equals to 1 over a. So I know that fx equals to 1 over a. I will substitute in our calculation for this part. 1 over a is a constant. I straight away take it out. So I left only the x squared inside the integration symbol. Okay, so integrate x squared. I will have x power 3 divided by 3. And I want to substitute the limit for a and 0. Okay, I take out the constant 3. Substitute the a inside. I will have a power 3 minus 0. And eventually I will get 1 over 3a squared after I simplify my equation here, my expression here. And now they're asking for the variant x. So to get the variant x, generally we need to apply the formula for variance x, where it should be ex squared minus the mean square. Okay, so what is the ex square here? It will be 1 over 3a squared, and the mean square that we list out just now is 1 over 2, a over 2. So we are having a over 2 squared. And if you try to simplify this expression, right, okay, we will be having 1 over 12a squared, which is actually the answer that they want us to show. Okay, so this is what we have for part C. And now let us proceed to part D. Okay, so for part D, they give us that the probability x smaller than b is equals to p, where the b is smaller than half a. Okay, so again, if we try to express it out in the diagram form for better understanding now, right? So this is the a. The center is the a over 2, right? And they told us that b is smaller than a over 2. So you can maybe try to put the b at here. And this whole area for b is p. Okay, and now they want us to find the probability of x between 1 over b and also a minus 1 over b. Okay, so first of all, I think it will be important if we can know what is the correct value for x smaller than 1 over 3b. If let's say x smaller than b is equals to p, right? So this whole area here is actually a p. And then when we are having b over 3, that means we separate or we divide. We divide actually this area into 3 equal parts, where I'm having this one is b over 3, and then this one will be 2b over 3, and until b. So the 3 parts are b, sorry, 3 parts the probability is a p, right? So if I am interested for this one small part here, this probability should be p divided by 3 because they are divided into 3 sections equally. All right, so for x smaller than 1 over 3b, we are having p over 3. And now let's proceed to find out how to get the probability for 1 over 3b from 1 over 3b until a minus 1 over 3b. All right, so let me cancel off everything that I don't want. Okay, so since we know that b over 3 is having the probability of p over 3, right? So the value a minus 3 b over 3, a minus 3 b over 3 will be a minus this distance. So minus this distance means that it will be somewhere here, where this is a minus b over 3. So this area and also this area should be the same, where I'm having this area is also p over 3. Okay, then if we try to find out the value where x is between b over 3 and also a minus b over 3, generally we are interested for the area in the center here. So how to get the area in the center? Since we know that both sides the area is equals to p over 3, right? So you should take actually 1 minus p over 3 and minus another p over 3. You have the minus 2 section for this p over 3, and to simplify the answer, you have 2 over 3p. Okay, so this is how we get the probability for this expression in terms of p. Okay, so this is how we solve this question number 6. Question 7. The mean time for Jenny's morning run was 28.2 minutes, and then she does some extra training and she wishes to test whether her mean time has been reduced. Okay, so maybe you can highlight this word reduce, where it is a hint, it is a keyword. for your alternative hypothesis. Okay, reduce. All right. So after the training, Jenny takes a random sample of 40 morning runs. She decides that if the sample mean run time is less than 22 minutes, she will conclude that the training has been effective. Okay, so you may assume that after the training, she run her time, right, has a standard deviation of 4.0 minutes. Okay, so first they want us to state the null and also how alternative hypothesis for her test. All right, so generally our alternative and null hypothesis, it will be related to the time that she for her morning walk for Jenny's morning run. Okay, so the mean is 28.2 and they are interested to test whether the mean time has been reduced or not. So this reduce is a keyword. All right, so for keyword of alternative hypothesis, mu should be smaller than, reduce is smaller than, and 28.2. Where the null hypothesis will be mu equals to 28.2. Okay, and part B, they want us to find the probability that Jenny will make a type 1 error. Right, so if we are interested in type 1 error, generally we need to know the definition where the type 1 error should be reject the null hypothesis when the null hypothesis is true. This is the definition for type 1 error. Okay, and then to calculate, to make it in our calculation for probability, the part reject null hypothesis, we should put in rejection region. So we actually need to find out what is the rejection region for this particular question. All right, so if I try to go back to the question again, so we can see this important sentence here. She decides that if the sample mean runtime is less than 27, okay, so highlight the keyword, you can see the word sample mean. So sample mean means x bar, less than means smaller than 27, so you just write 27. So they say the sample mean less than 27, right? She will conclude that the training has been effective. If the training has been effective, it means that the mean time reduced, right? Okay, so if mean time reduced, means that you reject null hypothesis, correct or not? Okay, the training has been effective means that the accept this one where the mean time reduced. Okay, and at the same time also it means that we actually reject the null hypothesis, and this means that the mean smaller than 27 is actually the rejection region. All right, so we are going to use this information to calculate the type 1 error. Okay, so let's start. Okay, so to calculate the type 1 error, generally we need to put in the rejection region where it should be sample mean smaller than 27, given that the null hypothesis is true. So the null hypothesis is true means that mu equals to 28.2. All right, so we are having this sample mean, right? Okay, because the sample size is large, if you have a look for the sample size, generally it is 40, which is large. So you can assume that it is approximately normally distributed. So for the sample mean, you have to change it become Z, where you take the value of sample minus the mean, which is 28.2, divided by standard deviation, which is a 4 given at this part, over square root n, so over the sample size, which is over square root 40. Okay, so use the help of calculator, right? We'll get the value negative 1.897. And this area is equals to the area exact greater than 1.897. So to find an answer, you have to take 1 minus the value that we get from the table. So 1.897, if we have a look for 1.897, we are having 1.8 here. 1.89 is 9706. 1.897 means that you have to add a 5. So 9706 plus 5, you get 9711. Okay, so I will write 1 minus 0.9711. So from here, if I try to simplify it, I will get 0.0289. This is correct to 3 significant figures. Okay, so this is how we get the probability for type 1 error. And before we calculate it, definitely we need the rejection region, and luckily the rejection region is given in this question. All right, so this is what we have for part B. And now let's proceed to part C. Okay, so Jenny found that the sample mean run time was 27.2 minutes. They asked you to explain briefly whether it is possible for her to make a type 1 error or type 2 error. Okay, so now our rejection region just now, is sample mean smaller equals to smaller than 27, right? Okay, then now you are having the, we can say that this is test statistic like observed value. This is the observed value. Observed value is 27.2. That means it is actually more than 27, and we actually didn't reject the null hypothesis. The null hypothesis is not rejected. Okay, when the null hypothesis is not rejected, that means you cannot make type 1 error, because type 1 error, the definition is reject the null hypothesis. So if the hypothesis is not rejected, therefore it is possible for her to make a type 2 error, but not a type 1. All right, so for the explanation here, you can write out like this. With the sample mean 27.2, the null hypothesis is not rejected. When the null hypothesis is not rejected, it is impossible for you to make a type 1 error, but you might make type 2 error. All right, so this is how we solve this question number 7, and we finish discuss this whole paper. Thank you very much for watching this.